Hi students, I wanted to provide some guidance on one of the questions from the take-home part of the midterm. Question number 2. A company wishes to manufacture a box with a volume of 32 cubic feet that is open on top and is twice as long as it is wide. We want to find the width of the box that can be produced using the minimum amount of material. So the first thing we notice on this problem is that the volume has to be equal to 32 cubic feet. So we're going to have to find the volume expression for this box. And the key here is we know that it's twice as long as it is wide. So if I let this distance here equal x, this distance has to be equal to 2x because it's twice as long. We know nothing about the height, so we'll have to label that a different variable. Let's call it y. Now to find the volume of a box, we have to multiply length times width times height. So the product of these three terms will give us the volume, which has to be equal to 32. That would give us 2x squared y must be equal to 32. This is called our constraint. Next, we have to consider the surface area of this box. The surface area would be the amount of material that would be needed in order to produce this box, and we want to minimize this. So let's let S equal our surface area. Now typically boxes would have 6 faces, but since the top is open, we only have 5. If we take a look at the bottom rectangle, that would be one face, and the area of that would be 2x times x, or 2x squared. Again, the top is open, so we don't have another one of those faces. If we take a look at the left side, the area of this rectangle would be x times y, but we have another one on the left, so we have 2 areas of x times y. Plus, now we must consider the front and the back. We know the height is y, so the area of this front rectangle would be 2xy. But since there's another one in the back, we'd have a total area of 4xy. This equation here represents the total amount of material that would be required to make this box. Let's simplify this. The only issue now is if we want to minimize this equation, we have to write it in terms of one variable so we can find the derivative, set it equal to 0, and solve. Let's take this information over to the next slide. What we can do now is use the constraint, solve it for y, and perform substitution. So if we take this equation, divide both sides by 2, we'd have 16 equals x squared y. Divide both sides by x squared, we have y is equal to 16 divided by x squared. So wherever we see y in the second equation, we can now replace it with 16 divided by x squared. So we'd have 6x times 16 divided by x squared, performing that substitution, plus 2x squared. Now you can think of this as over 1, so we have one factor of x that will simplify. So this would give us 96 divided by x plus 2x squared. Now, in order to minimize this, we're going to find the derivative and determine whether that derivative is either undefined or 0. So let's rewrite this in a form that we can find the derivative. We rewrite this as 96x to the power of -1 plus 2x squared. So now we'll find the derivative of this to minimize it. So we'd multiply by -1 and subtract 1 from the exponent. Here we're going to use our power rule. And we want to know when this is equal to 0 or undefined. So let's rewrite it again. By the way, I know this would be undefined when x is equal to 0, so that would be a critical number. But in this case, we can discard it because a box with width 0 would have 0 volume. So let's see if we can solve this equation. I'd probably move this over to the other side. So we'd have 4x is equal to a positive 96 divided by x squared. Now to get out of this mess, what I might do is put this over 1 and then perform cross products. This times this must equal this times this. So we would have 4x cubed must be equal to 96. Divide both sides by 4. We have x cubed is equal to 24. Take the cube root of both sides. X would be approximately 2.88. Remember, our volume was in cubic feet, So our width of the box is approximately 2.88 feet. I hope you found this video helpful, and thank you for watching.